In this video, we want to find the radius of convergence of the following sum. We're going to do this using the ratio test. So let's look at the limit as n approaches infinity of the absolute value of the n plus first term over the nth term. And so now what we do is we get a common denominator for the first fraction here. So n plus 1 factorial is going to be the common denominator, which means we need to multiply the second fraction by n factorial over n factorial. And in the bottom fraction, we need to multiply the second one by n minus 1 factorial over n minus 1 factorial, because the common denominator there is going to be n factorial. So now we have n plus 1 cubed minus n factorial over n plus 1 factorial, and then n cubed minus n minus 1 factorial over n factorial. Finally, the x to the n plus 1 over x to the n is just going to give us x. From here, I would like for this one to be n plus 1 factorial, so then I can cancel it out with this n plus 1 factorial. So I'm going to multiply the bottom fraction by n plus 1 over n plus 1. So it becomes n plus 1 factorial, and then I'm going to distribute this n plus 1 to the n cubed minus n minus 1 factorial. But first, the n plus 1 factorials are going to cancel. And here we still need to have the absolute value. So when I FOIL this out, I end up with n to the fourth minus n factorial plus n cubed minus n minus 1 factorial, and then multiply that by x. Finally, I can divide everything by n factorial. So the n factorial over n factorial becomes 1. Same thing over here, so these two become 1. Here, n plus 1 cubed over n factorial is going to go to 0. N to the fourth over n factorial, all of these guys are going to go to 0. So really what's left is a negative 1 over a negative 1, which is a positive 1. And that's going to be multiplying x. So we have the absolute value of x. And this has to be less than 1 in order for the series to converge. So we just want the radius of convergence. This is going to be the radius here, which is going to be 1. And that is our answer.